Lesson: Data cleaning and transformation techniques. Data cleaning and transformation are pivotal processes in the realm of data management for artificial intelligence. These tasks are foundational to ensuring that the data fed into machine learning algorithms and AI systems is accurate, consistent, and useful. Given the increasing volume of data generated globally, the complexity of these tasks cannot be overstated. Effective data cleaning and transformation are critical for deriving actionable insights and making informed decisions. This lesson will explore practical tools, frameworks, and techniques that professionals can implement directly to enhance their proficiency in these essential areas. Data cleaning involves the detection and correction of errors and inconsistencies in data to improve its quality. This process is often the first step in data preparation and involves activities such as handling missing values, removing duplicates, and correcting data entry errors. One common tool for data cleaning is Python's Pandas library, which provides powerful data manipulation capabilities. For example, Pandas' dropNA function allows users to remove rows with missing values, while fillNA can be used to replace missing values with a specified value or the mean of the column. These functions are particularly useful when dealing with large datasets that contain incomplete information, which is a common occurrence in real-world data scenarios. Another essential aspect of data cleaning is dealing with outliers, which can skew the results of data analysis and model training. Outliers are data points that significantly differ from other observations and can arise due to various reasons, including erroneous data entry or measurement errors. The z-score method or the IQR method are often employed to identify outliers. Once identified, outliers can be handled by either removing them or transforming them depending on the context and the extent to which they affect the analysis. For instance, in a case study involving a retail dataset, removing outliers led to a 20% improvement in sales prediction accuracy, demonstrating the impact of this technique on model performance. Data transformation, on the other hand, involves converting data from one format or structure into another. This process is crucial for ensuring that the data is in a suitable format for analysis and model training. One common transformation technique is normalization, which scales numeric data to a standard range. This is particularly important for algorithms such as k-nearest neighbors and support vector machines, which are sensitive to the scale of the data. The min-max scaling method, which transforms the data to a fixed range, is a popular normalization technique. The impact of normalization on model performance can be profound. In a study conducted on a dataset of patient health records, normalization improved the accuracy of a logistic regression model by 15%. Another vital transformation technique is encoding categorical variables, which involves converting categorical data into numerical format. This is necessary because many machine learning algorithms require numerical input. The Pandas library provides functions such as getDummies for one-hot encoding, which is a method of representing categorical variables as binary vectors. This technique was effectively applied in a telecommunications churn prediction model, where encoding categorical features improved the model's accuracy by 10%. Frameworks like Apache Spark also play a significant role in data cleaning and transformation, particularly when dealing with big data. Spark's DataFrame API simplifies the process of data manipulation and provides built-in functions to handle missing data and perform transformations efficiently. Its distributed computing capability allows for the processing of large datasets across multiple nodes, significantly reducing processing time. For instance, a financial services company utilized Spark to clean and transform terabytes of transaction data, leading to a 30% reduction in data processing time and enabling more timely insights. Moreover, the use of ETL tools such as Talend and Apache NiFi can automate data cleaning and transformation tasks, enhancing efficiency and accuracy. These tools provide intuitive interfaces for designing data workflows and offer pre-built connectors for various data sources. In a logistics company, implementing an ETL pipeline with Talend streamlined the process of integrating data from multiple sources, resulting in a 40% increase in data processing efficiency. While tools and frameworks are indispensable, the human element in data cleaning and transformation cannot be overlooked. Domain knowledge is crucial in identifying relevant features and understanding the context of the data, which informs the choice of cleaning and transformation techniques. For instance, in a healthcare dataset, understanding the clinical significance of laboratory values can guide the handling of missing data and outliers, ensuring that the data transformations align with medical realities. Addressing real-world challenges in data cleaning and transformation requires a holistic approach that combines technical skills with domain expertise. Professionals can enhance their proficiency by engaging in continuous learning and practice. Participating in data challenges, contributing to open-source projects, and collaborating with domain experts are effective strategies for gaining practical experience. In conclusion, data cleaning and transformation are critical components of data management for AI, directly impacting the quality and effectiveness of AI models. By leveraging practical tools such as Python's Pandas, frameworks like Apache Spark, and ETL solutions, professionals can address the complexities of real-world data and derive valuable insights. The integration of domain knowledge further enriches these processes, ensuring that data transformations are not only technically sound, but also contextually relevant. As the volume and complexity of data continue to grow, mastering these techniques will be indispensable for any professional aiming to excel in the field of AI and data management.